I don't wanna be. I do. I'm feeling groovy.
Hello, I'm the crazy macro guy, and this is my talk. Well, in fact, that's the working title of my talk, and as I worked on the talk, I realized that actually a lot has changed in Haxe 3. Not only macros, which were overhauled, a lot of things were changed, in the sense, well, let's just say enhanced, not just randomly changed. We have full pattern matching support in the language, and abstract types. These are all things that Nicolas talked about this morning. And the thing is that all these three things work together really well. And so it doesn't really make sense to talk about one or the other. Many things that you would have solved with macros before, now the language does for you, whereas macros can now do really crazier things, or nicer things, or whatever you want. Or things that seemingly look simple, but under the hood there's complicated stuff going on. And so the two main questions there are always about macros is how can I approach all this? How can I become somebody who understands these kinds of things and is not just scared by them? And even then, what do I need it for? I was asked that 2 or 3 times yesterday. I don't know. I couldn't live without macros, so that's maybe the other side of the thing. And what I will be trying to do in this talk, rather than introduce you to macros, which I already did last year, only to confuse a lot of people, is talk more about the symptoms of macros. Namely making Haxe a really extending Haxe to become an even greater language in some sense that it is, to your own personal needs. I will talk a lot about stuff that I've done, but the stuff that I need, and you may need other things, but just to give you an idea what macros can really do, how they can change the Haxe language to our personal needs, and yes, I hope that that will motivate you to get through learning those things, because it's really just a lot of work in the end. There's no secret. You just have to start, read tutorials. Simon does some stuff. Ask questions, ask me while I'm here. Ask me on Monday, there's a workshop. You can come in, you can ask any kind of questions, explain this, why does this work at all, or why doesn't it work? Both are very interesting questions, I think. Okay, so basically what I'm going to talk about most is Tinkerbell, that some of you might heard of. Slogan is Haxe on pixie dust, because steroids usually makes you like this, and Tinkerbell is really relatively small and tries to be magic in some sense. And so this is rational for the Haxe language design, is really to keep the syntax really simple and lean, so it's really friendly for newcomers. And you know, you always had these kinds of people talking to Nicolas, oh, but can you add this and this and this, and we want this, and this is nice, and it saves me 2, 3 keystrokes, and this one saves me 3, and this is better, and usually Nicolas says no. And usually he's right. But in some sense, I think it's important to enrich the syntax beyond what Haxe has to offer, to build your own domain-specific languages. That's an approach that is very common in Lisp, where rather than building big frameworks and stuff like that, you just build your own language suited for the problem, and then you write that down. And Tink works a bit along this line. Why? Okay. The most important reason is because it's possible. Not in every language, but it is in Haxe. That's why I like Haxe. And why else? The main reason is that at some point you are no longer a newcomer. So you have learned what there is to learn in Haxe. So you have a very good understanding of it. Because I think to really deeply understand, even without macros, this language takes some time. But you probably also made a long-term investment, because you went through all the trouble of learning Haxe despite somewhat lacking documentation, let's say, although that is getting a lot better. And you want to learn more, and you don't. One way to learn more things is to pick up a new language, do this, do that. But I think what's interesting in Haxe is that you can change the language itself, and thus learn more in the process about how you structure programs and even your models of things. So the reason why I stopped bugging at some point Nicolas to include all the stuff that I implement myself is that the main language will still remain clean. Everybody can make their own, let's say, version of Haxe, if you will, but the main language will always remain newcomer friendly, whereas that is not really true for other stuff, let's say Perl. So you say I like Haxe and you don't want this kind of stuff, and that's a good point, but what I'm also going to try to show that think in anything in that direction that you might do yourself can remain absolutely optional and granular, and you can plug it in where you need it, and you don't have to restructure your whole code base much like big enterprise frameworks try to make you do. So Tink is composed of a big set of libraries which I have to commit before Sunday, I think, because some people ask me they need that for their talks. Right now it's not on the new Haxe lib yet, it's on the old one, but this is about to change tonight. So you can choose among these things, and the interesting part is that they are really written to work well with one another, to compose and not to kick each other. Because when you try to change the language and everybody brings one feature and then you try to stick those things together, then suddenly it stops working. And it's also very small. The individual packages that I mentioned, they are all on average about maybe 1,000 lines of code. And the total project maybe has some, I think, 10,000 lines of code or something like that. But you get a lot of power out of that. So just a bit of history to mention. I first released parts of Tinkerbell about 2 years ago. At that time it was largely about macros itself, because the standard library didn't provide much in that direction. And it all once started out as the attempt to build the next big thing, a framework that solves everything and stuff like that, and of course it failed. But I took some very small bits and pieces of it, and that's what made Tinkerbell, because I realized that I need a better means to explain to the compiler what it is that I want to do. And this is how Tinkerbell happened. And it's now revised for Haxe 3. If you really want to have it right now, you can always get it on GitHub. But okay, let's just look at the core, because I said that Tinkerbell or Haxe macros also in a larger part can create new languages. And so here's the 5 types, that Tinkerbell is built around, in no particular order as I see. And this is not even yet related to macros, it's just to see, to explain these, because the rest of the Tinkerbell library is built around this. One thing that Tinkerbell introduces is outcomes. So when you have an operation that can fail, you just return this type of enum instead of throwing exceptions and stuff like that. So you get 2 different kinds of code. Here you would, this is how you would normally approach these things, say in the maybe Java-esque way. And in Tinkerbell you would just do it this way. But this is really just normal standard Haxe with a normal plain vanilla enum. The nice thing about outcomes is that in themselves they are values, so you can define some operations on them, and they are tucked right in the module where it is defined in Tink. And so you can, for example, start an operation that gets a JSON file and then map it, which means to transform it by means of a function, and then the outcome will in the end just contain the color there, for example. And then you can say, okay, I'm sure that this happened, and then you will in fact get an exception if you were wrong. But you don't get the exception where the problem occurred. You get the exception there where you make the assumption that the problem occurred, which is exceptions usually work the other way around. Classically, they are just displayed somewhere deep within the code, and you get a call stack like this, and you're trying to figure out what happened. So in this case, the call stack would start here, because that exception was not good to make to start with. And you can do some things like you can have one outcome and then try a different operation that will give you an outcome, and then you can map that to get the color, for example, and then you can get the outcome or use a value as a default. In that sense, you have all this error handling is just out of the way and it just works nicely. But again, this is just standard stuff. Then Tinkerbell has something called callbacks, which we all know in the end, but it wraps it in an abstract. If abstract make you nervous because you haven't heard of them until now, they basically almost behave like interfaces for the purpose of this presentation they do. And the interesting thing about a callback is that it can be implicitly converted from both a function that takes an argument and a function that does not take one. So for example, when you're listening for an event and you don't need the data, you can just throw in a function that doesn't consume anything, which also makes it sometimes easier to plug together stuff. And it only has this one invoking method. And one reason to make this, in fact, an abstract rather than use plain functions was that when you're passing around a lot of callbacks in your code, then you lose track what is a callback, what is a filter, what is a transformation, and stuff like that. So this type of thing just simply gets a name. Then you get links. These are just objects that represent that a callback has been registered somewhere, and you can dissolve the link, so then the callback no longer gets called when it should have been. And then you have a callback list. If you need to roll your own infrastructure that somehow where you can add callbacks to and invoke stuff or clear the list or stuff like that, you can just use this, and it's pretty straightforward to use. Exactly. So things built on this is, for example, futures. How many people of you have a vague idea what futures are about? Okay. But to summarize for the rest, a future basically just is a value that represents an operation that will finish at some point in time somewhere. And the way to deal with it is that you provide the future with a callback, and then you can pick off. Then you can continue when the value is really available. And then you have these kinds of things defined on them then to help you process futures and say, okay, when this is done, then I do this. This is usually done by map and fatmap and stuff. And you would just say, here you would see from the example above, you start getting a JSON asynchronously this time, let's say, and then you can wait for the result, which comes into this function, and you return another asynchronous operation, and in the end this gets tied together, and in the end you have your callback which just traces the data, because we needed something simple. And if you need to create your own future, there is this helper class that you can simply do, which happens to convert itself to a future when you need it, but you can also invoke on it. The important part here is that basically if you expose a future just to client code, it is not really callable. You can only register stuff. There are some flavors where everybody can call into it, but I don't like that. And so this is what I call a surprise. Some people call that promises or whatever you want to. And it's basically just a combination of the two things that we had. It's a future outcome, because in the future we're going to get an outcome, and it's going to be good, it's going to be get. And you can represent any asynchronous operation that can fail with this. Yes, because I like surprises. And it sounds nice, although it can fail. Right. Yeah, it has a nice ring to it. Oops, sorry. Okay, and then there's signals. Many people know signals, I hope. You know? Okay, this is a bit of an alternative to the event dispatcher that most of us have come to love. Tinkerbell also has its own flavor of signals. They are just built around these callbacks. You can turn a signal into a future, like, for example, get the next occurrence of the signal as a future. You can map those, you can dike, but that's okay, that shouldn't actually have gone in there. That's a bit advanced stuff. And if you ever need to have a signal that doesn't actually pass around data, you have noise. Which, by some neat trick, the type and the only value valid for the type, they are all called noise. So you can just make signals of noise and then call them anyway. And whether you register callbacks, if you remember, the taken argument or not is up to you, because there's this implicit conversion. Okay, and just maybe because I was first amazed when I discovered this. Just to talk a bit about the tools that are used here and how the language is used, the very basic aspects of the language. And this is a nice way to declare streams. Options are also by now included in the standard library. It's something that explicitly says this is a value or not. And so a stream can either be nothing, or it can be a piece of data that will come eventually, and the rest of the stuff. I think I got it the other way around. Okay, but in essence, it's important to see that with these kinds of very small things, you can compose a lot of stuff. Whereas usually, when you look at normal frameworks, you have a stream, and the interface declaration is big like this. And I think it's interesting to see how you can compose these small things, and then you can build a lot of code around them. And what is nice in Haxe that you can do a lot of things decentrally. You could add a lot of these big methods, usually defined in stream interfaces, by means of using, instead of having everybody implement this many methods. Then built on top of this is Tink macros, which in some sense is a bit outdated. It still can do very advanced stuff, but if you really want to know that, we can discuss it. Otherwise, I suggest for now that you stick to all the things that came in Haxe 3, because it's quite amazing. And so now let's have a peek at this language that I was talking about. It's pretty easy to use. This is, some people may know of auto-build magic. If you want to use Tinklang in a certain class, so it's not always going everywhere, but it's always in the scope that of your choosing, then you do this, and then within the class the language becomes available to you. And there's a whole lot of sugar. So let's look at these step by step. There's many things that you can do with loops that are not really possible in Haxe right now. You can, for example, step in either direction, or you can do these fancy stuff on maps, which I think PHP supports this natively, for example. You can loop through multiple collections at the same time, and you can also then give fallbacks. For example, this thing would, as soon as one of the two collections that are looped above are exhausted, it will stop. But you might as well want to continue, and then you can say, okay, if there's no more foos left, then just take this generic foo and continue the loop until there's no more bars. Or you can give both fallbacks, and it will loop until either of both is completely done. And so this is basically an attempt to deal with many requests for classical C loops that have been on the mailing list, which I think in some sense make it easier to shoot yourself in the foot. Because this stuff is always well defined. You have upper bounds and things like that. Whereas in C loops you can quite easily have the wrong variable somewhere and it runs infinitely. It was very frustrating for me. Here's what I think is a quite nice syntax I call trailing callbacks. You can, for example, the explanation is not very good because it's just the thing itself. If you denote something like this is an operator that is new in Haxe 3, which actually has no normal meaning, so it's really cool that you can assign new meanings to it. What this actually does is it does some async call P1, P2, and handler is included, and you can use that to kind of reduce this effect that at some point in your code it goes like this, with a lot of braces and brackets and parentheses, and this way you can do things more in fix. Then there's another feature that has been discussed a few times. There's basically even two notations, which I think is not so good, but for now this is a very young feature. So all these things that you're seeing, I'm very eager to hear input. Sometimes one is easier or the other is easier, but this is basically how they work. There is this metadata-based notation that you can use. The advantage of that is it becomes very short if you have no argument list, and it's just add f and you have defined your function. That's what it's actually for. But you can use it as you wish. And the problem is that you might want to have lambdas that don't return anything. This is one of the things that is ugly. Because actually Simon already took a shot at this, but he was never quite happy. So for now we have these two, I think there's these two kinds of syntax. This constructs lambdas that don't return values, because otherwise Haxe is going to complain that you're trying to return void and everything will blow up. So you have these. It's important to note that these two are in fact very similar. I mean, this one is only for you if you really if 3 characters matter for you. But again, if there's no argument list, it actually looks quite good, and it also reads quite well. Although this arrow there shouldn't be there. Okay, I'm sorry, but there's going to be another example. So here you would, for example, see how this might work put together with the trailing callbacks I was talking about. This could be some JavaScript code, and you just say, when my button is clicked, then do this, and you know, I mean, I think it's quite evident what it does. It's good to read. It's not. It's, I think, a lot harder to write in some sense, because you have to learn all these crazy rules that I'm showing you. But once you do that, you get code that becomes really small and reads a bit closer to human language. Let's not exaggerate. There's short bindings. This was actually the first proposed syntax for replacing callbacks. So basically you can just do that whenever you need to. I'm not sure this is even good. This might get lost at some point, suppressed. And then there's a pretty nifty feature, I think, which it looks like this. So you can say when some signal occurs, then you have this handler. And the same is for futures, and the signal can become a future, as we have seen. So it could, for example, look like this. When my button is clicked, then do trace clicked. Or there is a special syntax for old events, you know, with event dispatches and stuff like that, because unfortunately some of us have to do with this. So Tinkerbell does not try to impose what you use, just rather try to give you small languages that solve some problem. So then there's until. Okay, now if you bear with me for a moment. This is how you sometimes implement dragging when you need to handle it. As soon when the mouse goes down on some button, then on the, I mean this is very Flash specific. If you have never had the pleasure of Flash, you might not understand why this is maybe much shorter than it often has to be. So, but you say when the button is down, the mouse is down on this button, then do, and then comes the next handler, until the mouse goes up anywhere on the stage. When the mouse moves anywhere on the stage, you trace this is a drag event. If you remember how much code this really takes an ActionScript 3 to write down, it's a nice trick at least. And there's also, if you don't want to repeat yourself so much, you can, there's this with thing, and then anything that appears in those when clauses will be in fact resolved in there. So yeah, this is also okay. I write this kind of stuff, and it combines well with the rest of the things. Okay, and this is some other really quite nice feature, I think. I've been doing a lot of Node.js recently, which can be quite painful. So I came up with one thing. I think it's quite a good idea to handle ways. And this is a syntax that what you really do. You have object literals, if you will, that are connected through these arrows. And what this does is it executes all these operations and binds them to the results. And in this next scope, they are already available. And in the end, you do something. And in fact, whether it's asynchronous or not does not matter. So you can run if you have an API that looks the same on PHP and Node.js, but only one returns values directly and the other one returns futures, the code will run the same. You could just write a constant there. Instead of operation 3, you could write 5. That would still work. This is done through some magical automatic conversion that abstracts allow us. I will not try to explain it now because I think it will only confuse you, but if you're interested, come to me. If it's too much sugar at some point for you, and because things maybe start breaking, or there has been something introduced in Haxe, some syntax that might conflict with Tink, it's always important to escape. And you just do that by prefixing. So doing this, for example, would cause a compilation error because the Haxe compiler does not recognize the syntax while Tink does. Usually you want it to do the other way around. Tink might sometimes choke on stuff, although I think it works quite well. And then you can just say, okay, this bit of code, please use normal Haxe. Because usually once you declare a class to use Tinklang, you have it in all the class, and that might just be too much at some point. And then there's some class level things that you can do, which are also quite nice. You can initialize stuff, a declaration. This has started to work more and more in Haxe, but only with constants. You can do it this way. Underscore is special in that this is simply provided in the constructor, so just ask for it. You can do forwarding, which I think is a really nice feature that maybe even might make it into the language at some point. So you want to, for example, construct a stack, but you don't want to expose all of the interface that goes with an array. So you can just really say, upon this member that I have, I want to forward these methods to. This is relatively old, but I think it's quite. It's also quite proven, I think. I have to say that in the past year I haven't used subclassing so much, which I think is not so bad. Properties. This is also a notation that has survived Haxe 2. Luckily enough, any code that was written with this property notation compiles on Haxe 2 and Haxe 3 the same, because the difference between syntax is just really hidden. This will, the property tag will simply declare accesses with default implementations that just provide access to the field. If you specify one, then it will be taken instead, of course, so you have full control. Then you can also define signals and futures. So you can say, okay, I have the signal that produces strings, or I have this signal that if you do nothing, then it just provides noise. And if you don't initialize it, it's going to be initialized with a callback list that we've seen up above, which is something that you have control over. But from the outside, people are only going to see plain signals. And you can start mapping signals and stuff like that. You can initialize this to anything you want, like for example a signal that belongs to another class, and you can just expose it as your own. Or take the signal from the other class, map it, and then give back some different data. So this is a nice way to quickly move signals around. It's also interesting that the forwarding that we've seen, it will of course also forward signals if you want that. So you can just say, okay, of the class that I'm wrapping, I want this and this signal exposed. Same goes for futures. They don't always have to be so dramatic. And there's one thing called partial implementations. If you use Tinkling on an interface, then you can provide default implementations. And if you implement the interface and an implementation is missing, then it will be taken from the interface that declares it. So for example, you can do this, and as soon as you declare a for each, you will get the filter for free. Unless you have some own stuff for yourself that you think is better on your data structure, of course. Then you implement it by hand. This is sometimes also referred to as trades, also everybody has a different terminology for it. There's one limitation though, it doesn't work with using, because using is lost. This is declared in some scope, and if in the other scope where the implementation is inserted, you don't have the same usings, then the code just doesn't compile, because the whole mechanism is relatively dumb. So yeah, but you can do funny things with it if you need to compose stuff. It's, in some sense, it's a complement to forwarding, but well, in essence, you have to figure it out. It's not always clear what is appropriate and what is not. So, how far along are we? In fact, oops, sorry, I was talking quite fast, I think. Okay, when did we start? Nobody knows. Okay, so to conclude, I would say I hope this didn't intimidate you further, but instead gave you an idea what it is that you can do with macros. Whether you like Tink or not doesn't really matter. You can build these kinds of things yourself with a reasonable effort. Of course, you have to learn macros first, but once you're there, you can do this, and it's usually really worth. It's an investment worthwhile, because you can just start writing code that looks really, really good, instead of using big frameworks that introduce a lot of noise and things that basically just tie you down, and you write a lot of code, and then you get attached to the code, and you can't change things, and you know, all these kinds of stuff that we have. So I think, yes, try to learn macros. You should. If you can't, try to use Tink or other macro-based stuff that is out there, because it's important that the authors of those libraries get feedback, and that they can get more feedback to the people in the compiler team who make all this amazing stuff work in the end. And yes, please just get involved with all this Haxe craziness, because Haxe can be a lot more than just JavaScript or ActionScript with weird stuff. So yeah, any questions? Yes, please.
You in the thing, I don't remember which library, but the @when and the other stuff.
Yes.
Maybe you can go a slide back so I can remember.
Which one? You mean the syntax? I don't know. Oh, where was this?
Yes,
this one.
This
okay.
one. I was wondering how you did the @with and the @when. Is the metadata
that's a new
on the
syntax. Okay. Yes. To maybe, if that answers the question, you can use arbitrary metadata within expressions, starting with hex 3.
Nice.
Yes. Which I never explained Nicola why I wanted that, but I think now he sees. So yes, you can just mix them in your code. The compiler is going to just discard it at some point, but if you have a macro that's quick enough to grab this information and do some transformations, then you can do funny stuff. Any other questions? Lawrence, thank you. Oh, okay, then this gentleman.
One quick question. What's the difference between declaring properties and a public variable?
I'm sorry, okay, let's just look at... it's even here.
Yeah.
What the difference is basically that in this case you have a getter and you have a setter.
Yeah, okay.
And maybe they are just plain ones, but you might need that to conform to an interface, which requires you to have a getter rather than a plain variable. You think that it might be a good idea to at some point subclass it and override the accessor or stuff like that. I mean, there's people who are, and at the time when I wrote the feature, I think I was too, who are very religious in saying that you should never expose a plain field. You should always have a default accessor, and I think there is something to it, although there's no need to be black or white.
Okay, I'll try it. Hello.
Hello.
Trying to subclass classes and do fluid interfaces at the same time is something I'm kind of interested in. Like, you have a promise, but if you can subclass it and still have the flat map and map work, this is something complicated in typing, I suppose, but it would be interesting to do.
So you have a promise of some type, and then you subclass this type?
Yes, and still have the ability to make it monadic, or have it return itself typed correctly.
I think that's also a bit of a language issue, more than I mean, you can go and start generate crazy amounts of probably type defs rather than classes, because the restrictions are smaller, but it's hard to do. Yeah. I think for now, but
okay.
Maybe after your talk tomorrow I'll understand more.
I don't know how to do it, so I'm asking you.
No, the issue better, and then I have a better idea. But right now, I think it's really.
So it's not something. It's not something you've thought about, or it's not something that is possible.
I mean, it's something I've often thought about. There's always every 2 weeks or so there's the request for the self type and things like that, and Heinz always works on these higher types, and I'm always reading it and trying hard to understand. It usually works. So yes, I thought about it, but in the end, for now I can live without it.
Yeah.
I guess once I get used to it, I will not want to go back, but
Okay.
Haven't had the comfort yet.
Yeah, confusing question, I'm sorry.
Okay.
Do you think using this kind of syntax sugar in a library as opposed to in your own project has any effect on someone who might want to use your library, but is it completely isolated? I guess that's what I'm asking. So if I want to use it in a library and then someone out there wants to use my library but doesn't have yours installed, or it's just installed as a dependency, will they get any of the sugar if they don't ask for it, or is it?
No, as I said, the basic usage is it all starts here.
Okay.
If you don't do this, then all this stuff stays out of your way, and that's important. I mean, because you don't know how many crazy people might have some ideas about how a language should look like, and then they start fighting each other, and nothing compiles.
Yeah. Good.
The guy at the back.
There's a question from someone on the list, actually.
Okay.
Someone called Simon. But it's rather for Nicholas, I believe. He asks, why don't we have short lambdas in the language?
There's a microphone. Yes, I mean, I think it should go into the language at some point. I think it's only a matter of time anyway. Everybody just write 2 emails today to Nicola about Okay, that's it, I guess. Okay, thank you.